Hello, we want to discuss the derivatives of the exponential functions. Now, f of x equals e to the 3x is an exponential function. What is its derivative? So let's just go back to the one we know from calculus. The derivative of e to the x is e to the x. Now, what about the derivative of e to the 3x? So it's a question mark. So, if in general, if you have f of x which is equals to e to the ax, its derivative is e to the ax times the derivative of the exponent, which is just a. So the derivative of e to the ax is a times e to the ax. For example, so y equals e to the 3x. So the derivative of y equals e to the 3x is going to be e to the 3x itself times the derivative of the exponent, 3x. So that makes it 3 times e to the 3x. So we can summarize this as if your function is given as e raised to the power f of x, then its derivative is e to the power f of x times f of x prime. If e to the sine x is your function, then its derivative is e to the sine x times the derivative of the exponent of e, which is sine x. So you end up with cosine x times e to the sine x. The derivative of e raised to the power 3x squared plus tangent x. So it's going to be e to the 3x squared plus tangent x times the derivative of the exponent. So the derivative of 3x squared plus tangent x, which give us 6x raised to the first power. Okay, so it's going to be 6x plus secant square x. Now, we go to a different exponential function where 3 is different from e. So we have h of x equals 3 to the x. What is derivative? So there is a small proof here. If we can write x as e to the ln of x, because ln and then e cancel each other out, and you have x. So then e to the ln of f of x is going to be equals to f of x. Because we have sun here, sun there. So e to the ln over 3 to the x is going to be 3 to the x. So we change 3 to the x as e raised to the power ln over 3x, 3 to the x. These are the two are the same. They look different. But now we want to express 3 to the x as an exponential function, because we already know how to take the derivative of exponential function. So from here, since 3 is the x is the exponent of 3, we can drop it right in front of natural log to get e raised to the power ln of x, ln of 3 times x. Now we're going to take the derivative. So 3 to the x is e to the x times ln of x. Its derivative basically is itself e to the f of x times f prime of x. So then we get, so here we use the ln of 3 is a number. So when you take a derivative of x times ln of 3, you just get ln of 3. And then you change this back to the original function. So e to the raised to the power x times ln of 3 is a 3 to the x. So the answer is 3 to the x times ln of 3. H of x equals e to the x. So the derivative of a to the x times ln of 3 of a. So this a is the one you see there. For example, if you're asked to find the derivative of this, so what we said is the derivative is going to be the function itself times the derivative of the numerator. So the derivative of sine x is cosine x, and then times ln of ln of 5. Okay, so it's going to be a to the f of x times ln of a, and then times f power of x. So that's what I did there. And so last example. So g of x equals 10 raised to the power x squared plus 2x plus 1. Its derivative is going to be itself times we have h of 10, because it's going to be here, h of 10, and then times this prime, x squared plus 2x plus 1 prime, which gives us 2x plus 2. So that's the answer. Okay, thank you very much.